Hi everybody, it's Miss Lahosky here today, and I will be talking to you a little bit about the concept of circumference within a circle. So before we begin, it's really important that we have two foundation pieces of knowledge that we need to know before we begin. And those are the concepts of radius and diameter. The concept of radius is the distance from the center of a circle outwards. Diameter is the distance straight across the circle. As you notice in my visual models, the radius starts from the center of the circle and goes outwards. A way that helps me remember radius is if I connect both letters, the radius, I can create the letter R. This helps me remember that radius was the distance from the center of the circle outward to any point. With diameter, this is the distance that's straight across the circle. A way that helps me remember diameter is if I draw my line directly across the circle and I connect the two lines, it forms a sideways letter D. This is a visual way that helps me remember diameter when I form it into a letter D, diameter going all the way across the circle. It's these two pieces of knowledge that's really going to help us figure out problems that are addressing circumference. Now, circumference is the distance around the entire circle. So if I start here in a pool and I swim an entire lap around, that is I swim the circumference of the pool. Now, this is important to remember because circumference is represented by the formula C equals pi d. When we represent circumference in this formula, C equals pi d, it's really important that we're aware where pi is on our calculators. So, if you go ahead and grab your calculators, you'll take a look, and that pi button is going to be your fourth button down. 1, 2, 3, 4. This is where you'll find pi on your calculator. In order to solve a circumference problem, you have to have an awareness of what radius and diameter are, as mentioned. So, for example, if I start with a circle and I'm given a diameter of 10, I'm going to use this formula to help plug in the information I know. So I'm going to rewrite the formula. And as mathematicians, rewriting formulas is going to be the perfect place model for helping us do accurate work, so it's important to do so. I start with C equals pi d. Then I rewrite my formula, and I'm solving for circumference, so I still don't know that value. So C equals, I rewrite the visual of pi, the symbol, and I can tell on my circle that diameter, looking at this D in a visual manner, my diameter is 10. So I've rewritten my formula as C equals pi 10. With my calculator, I'll rewrite my formula, but instead of pi, I'll be pressing pi on my calculator and multiplying it by the numeral 10. When I do so, I receive the answer of 31.41. Now, many times we'll be asked to round to the nearest tenths place, so if I look at that tenths place, the value after it, here it's below 5, so my final answer is circumference is 31.4. Now, circumference can be as simple as plugging in information when given the diameter, but sometimes we're given circles and we're given the radius. So, for example, if I have a circle and I'm given a radius of 4, I'm going to rewrite the formula of C equals pi d. Now, as we know, radius is going to be double what your diameter is. So we're going to double radius to get our diameter. So C equals pi. Now, if I walked to the center of the field and took 4 steps, I would need to take another 4 steps to get to the other end of the field. So my diameter for this circle is actually 8. So with C equals pi d, I'm going to write 8 as my diameter. If I rewrite my formula and use my calculator to multiply pi times 8, I get the answer of 25.13. And since we're rounding to the nearest tenths place, I know I'm not changing that 1. So my final answer is C equals 25.1. That was our basic tutorial on circumference, and we'll be posting more on area soon. Make sure to check out the radius and diameter tutorial if you haven't seen that yet.